Good afternoon to you viewers and subscribers, and welcome to another video, and I thank you for watching this video. Now, in my last video presentation, I have gone over doing the slump test. I have looked at the procedure of how that test is done, and in this week's video I'm going to be looking at the ear test. I want to point out something to you before I begin my actual presentation, and that when it comes to the slump test, the temperature test, and the ear test, along with the curing and breaking of the concrete specimen to determine the compressive stress of the concrete, this is a very critical procedure to be conducted on site. Now, this is very critical, especially if you're doing a commercial building where that building is going to be occupied or used by a large volume of people, or if you're doing a multi-story building. And if you do not do this, you have no way or means to know if the concrete that you're using to pour these structures are good enough to carry the load capacity of the structure. And that is very critical, because without you knowing the strength of your concrete, you don't know to what level or to what extent that structure can carry the loads. I know that some people might not find it necessary to have these tests done on your construction site, but from my experience, I can tell you that you're making a big mistake, because your quality assurance and the quality control of your construction material, especially as it relates to the concrete and the concrete blocks that you use to construct your building, is the chief component that forms the structural integrity of your building. So without you carrying out these tests, you have no way to verify how strong your concrete is, and if your concrete is strong enough, can withstand the elements, especially in the case of an earthquake. So I can't stress this enough, that you should pay attention to these tests. I'm not saying that you should be an expert at them, but it is very worthy to know that these tests is supposed to be carried out on your construction site. Another type of construction where these concrete tests are crucially important is when you're constructing a concrete pavement or a rigid pavement or even bridge construction. These tests are vitally important, because without you doing these tests, you're not going to be able to verify or to know what type of concrete or the strength of your concrete that you're using to pour these structures. So you have to carry out these tests, the slump test, the temperature test, and the ear test, along with the breakage of your cylinder, to know the compressive stress of your concrete, to know if your concrete meets the minimum criteria to carry these loads. So without further ado, I'm going to be getting into the presentation of how to do the ear test for freshly mixed concrete. The test method for air contents of freshly mixed cement concrete by the pressure method is governed by ASTM C231/C231M. Now, I want to point out to you that there are two methods of carrying out the ear tests for concrete. There is the volumetric method and there is the pressure method. But for the purpose of this presentation, I'm going to be taking you through the pressure method. Now, in order to carry out the ear test for concrete, you have to be familiar with the testing equipment that is used to measure the air content in your concrete. And if you look to the right of my screen, you will observe the testing equipment that is used, and make sure to observe the different parts or the different components of the testing equipment, because I'm going to be making reference to some of these components during the course of my presentation. The test method can be used to determine the air contents of normal and heavyweight concrete. The test will both determine the amount of entrained and entrapped air voids in the concrete. Air entrainment is necessary in concrete that will be exposed to cycles of freezing and thawing and to de-icing chemicals, example, rock salt. So let me expand on this a little bit more. The air entrainment is placed in concrete that are going to be subjected to freezing and thawing, and the de-icing agents is placed on the concrete surface, primarily our bridge deck, because most of the bridge deck here in America is paved with rigid concretes or concrete pavement. So the de-icing agent is placed over that surface whenever times we are going to be hit with a snowstorm, and that prevent the snow from turning into ice and making the road surface, the concrete surface, becomes more hazardous for the traveling public. Now, in Jamaica, we are in a tropical region, and I do not think it is necessary to have air entrainment in our concrete. But nevertheless, I just think this is a worthwhile piece of information that I should bring to your attention. Without proper air contents in the mortar of the concrete, normal concrete that is exposed to cycles of freezing and thawing will scale and or spall, resulting in loss of strength and durability of the concrete. So if you look to the upper left of my screen, you will see what scaling looks like, and you will see what spalling look like. In the case of scaling, if you notice the areas on the surface of the concrete that is deteriorated, that is a representation of scaling. And in the case of the spalling, you will see that the outer surface, or what is known as the concrete cover or the concrete clearance, has fallen off from the concrete surface, leaving the rebar exposed. And that is a situation that you would want to avoid, because when you have your rebars exposed, your rebars are now going to be subjected to rust and pitting. Hence, the deterioration of your rebar is going to occur, and hence weaken your structure. And that is a very untenable situation. You don't want to have your concrete experience this type of situation. Care must be taken not to have too much entrained air in the concrete. In concrete designed to produce 20 to 35 megapascal or 3,000 to 5,000 psi, pounds per square inch, as the air content increases, say above 5%, there will be a corresponding reduction in strength of the concrete. So generally speaking, air voids reduce the strength of your concrete. So for every 1% increase in air voids, there is a corresponding 5% reduction in strength of the concrete. And that is why it is critically important to check the amount of air content in the concrete to ensure that the air voids are within the required limits. The steps that are taken to carry out the air test for freshly mixed concrete are as follows. Step 1. Dampen the interior of the bowl. 2. Use a scoop to fill the bowl to approximately 1/3 of its height, with concrete of course. And 3, you're going to rod that layer 25 times uniformly over the cross section with the rounded end of the rod. You're going to rod throughout that layer or throughout that depth, and you must take care not to damage the bottom of the bowl during rodding. Tap the sides of the measuring bowl 10 to 15 times with a rubber mallet to close any air voids that are left by the tamping rod, and to release any large bubbles of air that may have been trapped. Now for the second layer, you're going to fill the bowl to 2/3 of its height. Then you're going to rod the layer another 25 times uniformly over the cross section with the rounded end of the rod. And you're going to rod through the second layer and penetrate the first layer only by 1 inch or 25 millimeter. 7. You're going to now tap the sides of the measuring bowl 10 to 15 times again with a rubber mallet to close any air voids left by the tamping rod and to release any large bubbles of air that may have been trapped. Now for the third layer or the final layer, you are going to fill the bowl to its full height. Then you're going to repeat the process of rodding 25 times over the cross section with the rounded end of the rod, and you're going to rod through the third layer and only penetrate the second layer by 1 inch or 25 millimeter. Then you're going to tap the sides of the measuring bowl 10 to 15 times with that rubber mallet to close any air voids left by tamping rod or to release any large bubbles of air that might have been trapped. So that is it. So where that is concerned, the tamping, ensure that you're tamping and you're only penetrating each layer by only 1 inch with the exception of the first layer. Now step 11, you are going to strike off the bar across the rim of the concrete bowl with a side motion until the concrete is totally level. And if you look at the picture to the upper left, you will see the screening off of the concrete on top of the measuring bowl. Step 12, you're going to thoroughly clean off the excess concrete around the rim of the measuring bowl. And 13, you're going to clamp the covering assemble to the measuring bowl, ensuring a pressure tight seal. And if you look to the upper left of the picture on screen, you will see what the cover assembly looks like. Then step 14, you are going to now close the main valve between the air chamber and the measuring bowl, and you're going to open both petcocks on the cover. 12, you are going to now use a syringe to inject water through one petcock until water emerges from the opposite petcock. So the cover assemble is affixed with 2 petcocks, one on either side. And if you observe the picture to the left again, the second half of the picture, you will see the person demonstrating how you use the syringe to inject water in one of the petcock. Now, based on my experience, I have personally carried out these tests already because I am ACI certified, and while I was working on my construction site, sometimes when you use the syringe to inject the water in one of the petcocks, the water does not emerge on the opposite petcock. So what you want to do in circumstances or situations like that, you have to disregard that test and restart the test from scratch. Step 15, you're going to close the breather valve and pump into the air chamber until the hand on the dial gauge is on the initial pressure line. 16, you're going to stabilize the gauge hand at the initial pressure line by bleeding, pumping, and lightly tapping the gauge by hand. 17, you're going to now close both petcocks. And step 18, you're going to open the main valve between the air chamber and the measuring bowl, and then you're going to tap the sides of the measuring bowl smartly with the mallet, and then you're going to lightly tap the pressure gauge by hand to stabilize the gauge hand. Now, the final step in this procedure, you're going to read the percentage of air on the dial gauge of the pressure gauge to the nearest 0.1%. Ideally, you'd want to have your air content between the range of 4.5 to 7.5%. Now, in the event that you're not getting that reading of 4.5 to 7.5%, you can get a fresh sample of concrete and redo the test. And if the result doesn't change, then you will have to inform the concrete plant that the concrete does not meet the criteria of the ear test, and they will have to take remedial action by dispatching another concrete truck to the site, and then you have to redo the ear test until you get a reading of between 4.5 to 7.5%. So that is it for this video, and I hope you find the video interesting. If you like the video, please hit the like button. Do remember to subscribe if you're watching the video for the first time, and I will see you in another video upload. Thanks.